One of the most important developments for humans in terms of space observation is the James Webb Space Telescope. The scientific community has great hopes because it will be much more capable than any other space telescope ever deployed by humans. They will be able to investigate very far-off space objects, something they have never been able to do. Proxima b is one of the things the JWST will observe to determine if the planet is emitting artificial light. Yes, what you heard is true. If aliens are responsible for the lights coming from Proxima b, scientists want to know. How does the JWST's concentration on the exoplanet influence you, and what will it see? Join us as we explore the Proxima b discovery by James Webb that changes everything. Let's jump into the video without wasting any time. The universe is filled with exoplanets, which hold a lot of secrets. Any planets outside of the solar system fall under this category. Rogue planets are free-floating exoplanets that orbit the galactic center without being bound to any star, unlike the majority of them which orbit other stars. Exoplanets are numerous, but the majority that have been found so far are concentrated in the Milky Way, a very tiny area of our galaxy. Actually, the galaxy contains more planets than stars. Scientists can see compositions ranging from very rocky, like Earth and Venus, to very gas-rich, like Jupiter and Saturn, by measuring the diameters and masses of exoplanets. Exoplanets are composed of the same elements as the planets in our solar system. It is possible to have planets that are dominated by iron or carbon on some, and by water or ice on others. The density of styrofoam, fluffy planets, lava worlds with molten seas, and dense cores of planets still orbiting their stars have all been discovered by astronomers. Since the initial exoplanets were found in the 1990s, hundreds have been located using various detection techniques. However, it is quite uncommon for astronomers to observe an exoplanet through their telescopes in the same way that you might observe Saturn from Earth. Only a small number of exoplanets have been discovered by this method, and those that have tended to be young gas giant planets orbiting very far from their stars and are known as direct imaging exoplanets. Scientists must employ indirect techniques to find these exoplanets because they are difficult to notice using current telescopes. Measuring a star's dimming when a planet occurs to pass in front of it is one indirect method. This process is referred to as transit. Monitoring a star's spectrum for telltale evidence of a planet pulling on its star and causing its light to gradually Doppler shift is another technique used to detect exoplanets. By watching transits, the modest dimming of a star's brightness as its tiny planet passes between it and our space telescopes have discovered millions more planets. The so-called wobble method, gravitational lensing, is one of the additional detection techniques. Finding exoplanets is very challenging. Webb telescope finding an alien society is scary, but investigating it is even more difficult. Due to this, astronomers have not been able to fully examine Proxima b, one of the most well-known exoplanets, despite all the amazing things they believe it may be hiding. Does the exoplanet, for instance, support alien life? But now that James Webb Space Telescope is available, they have a new tool at their disposal. The JWST is not the first telescope that humans have launched into orbit. NASA has a lengthy history of studying the universe with powerful observatories that have been flown into orbit. The Hubble, which has accurately provided spectacular photographs of many areas of the universe over many decades, is one of the most recognizable and strongest. However, the JWST is both far more expensive and more powerful than the Hubble. The JWST was launched at a cost of over $10 billion, making it the most expensive telescope ever. In addition to being the most intricate, it has a number of foldable sections. They had to be folded up in order for the telescope to fit on the rocket that would send it into orbit. The JWST is located extremely far away from the Hubble. The former revolves about the Sun at a distance of roughly 1 million miles from the Earth, while the latter orbits the Earth at a distance of around 350 miles. This means that after launch, NASA will be unable to send astronauts in to fix or reassemble the JWST. The James Webb Telescope can record objects that are billions of light years away because of its larger primary mirror, which measures 6.5 meters across. This effectively transports us back in time. Since we can now go as close to the Big Bang as possible, the JWST will really allow us to take earliest photographs of the universe. The new telescope detects heat-emitting objects hundreds of kilometers away using infrared technology. NASA installed a shield under the telescope to shelter the observatory from influence from heat from the Sun and Earth. The 5-layered shield is so big that it would completely enclose a tennis court. In order for the JWST's 18 main mirror segments to correctly align before it reaches its full capacity, NASA has released a mosaic of the first photographs the telescope took. Even though the image is grainy, it is an excellent place to start in the lengthy process of modifying JWST's mirrors in order to acquire ultra-sharp pictures of the far-off universe. The 18 visible points of light in the image are all the same star, HD 84406, as seen by various primary mirror segments. It took almost 25 hours to gather the light necessary to create the image mosaic. The 18 photos of HD 84406 were assembled from more than 1,500 photographs taken when Webb was oriented in different directions around the star's anticipated location. Following the various adjustments that the telescope will make over the upcoming months, the mirror will start to line up appropriately, and the 18 stars will eventually merge into one as all of the mirror segments are lined up to form a smooth surface. So why are astronomers interested in the Proxima b exoplanet? You must be aware of its position in order to understand this. The Proxima Centauri star is around 4 light-years away and is our closest neighbour. Proxima Centauri has its own group of planets around it, just like our Sun does. A planet in the Proxima b galaxy, scientists have been fascinated by this exoplanet ever since it was found in 2016. Proxima c have also been found by researchers, while Proxima d is still awaiting confirmation. But Proxima b has gotten a lot of attention, and with good reason too. The planet could harbour liquid water and possibly even life, since it orbits in the star's habitable zone right in the centre. Proxima b could be both a rocky terrestrial planet like Earth and have liquid water due to its mass, which is similar to that on Earth. Despite being near to our solar system, Proxima b revolves around a star that is significantly paler and less massive than the Sun. The exoplanet has a light side and a dark side, with one side constantly facing the star and the other always facing away, since it is tidally locked and rotates synchronously with its star. It's also unknown whether Proxima b has an atmosphere. However, if Proxima b has an atmosphere, the basic components that are required for the emergence of the biochemical cycles that constitute life, water, carbon dioxide, and rock, could all be present and interacting on the planet's surface. The planet orbits its star once every 11 Earth days, while being extremely close to it. The planet's surface might have a temperature of -90 to 30 degrees Celsius, or -130 to 86 degrees Fahrenheit. What if Proxima b is inhabited by aliens? If that's the case, it's thought unlikely that life could arise on the day side because of a steady stream of powerful radiation from its host star. We will try to explain it in simple terms. The Proxima b orbits the Sun at a distance of only 4.5 million miles, or just a tenth of the distance Mercury travels when it is closest to the Sun. Radio astronomers believe that the radio signals that have already been picked up from the vicinity of Proxima b were probably just interference from natural sources. Therefore, any civilization that inhabits the exoplanet may need to deploy strong mirrors or use extremely brilliant LED-style lights to illuminate their cities, because the side of the exoplanet that is free from radiation is constantly dark. If we use the correct tool, this can assist us in finding them. For this reason, a group led by Harvard astronomer Avi Loeb has proposed that the JWST be set up to look for signs of LED light on the planet Proxima b. They claim that if artificial light is present, it will be detectable using the near-infrared instrument on the James Webb telescope and searching for telltale traces of LED light waves in the light from the planet and its host star. Computing light curves from Proxima b and its host star allowed the researchers to examine whether artificial lights may be seen on the planet's dark side. The two scenarios that these researchers looked at were artificial illumination with a spectrum identical to that of commonly used LEDs on Earth, and artificial illumination with a narrower spectrum that produces an equivalent amount of light to all artificial illumination on Earth. They found that 5% of stellar power, represented by LED-style artificial lights, would be detectable by the JWST. James Webb will be able to define the planet's atmosphere if he is able to identify the narrowband light characteristics of LED bulbs. Researchers will then be able to calculate light curves to see if they match those of an LED light source or not, using devices on the observatory to gauge the amount of energy that is transported around the planet. Loeb and his colleagues utilized the JWST exposure time calculator to determine that it could be able to detect artificial light. Before the observatory is launched, astronomers can use this program to estimate what can be observed over any particular time period depending on predefined settings. They were able to assess whether they could detect various flux values and those with wavelengths that correspond to the artificial light levels that would be expected from a civilization that was compelled to dwell in perpetual darkness. In such a situation, the lights illuminating the permanent night side ought to be quite strong, making them more likely to be picked up by JWST. Aside from conventional LEDs that are 500 times more potent than those found on Earth right now, the JWST will be able to demonstrate the existence of artificial illumination that is of an equivalent size to that of our planet. Well, that pretty much wraps this video up, guys. Thanks for watching. Let us know what you think about the JWST finding aliens on Proxima b in the comment section below. Remember, be sure to subscribe to this channel with the bell notification if you enjoy watching our content. We upload some pretty awesome stuff here, which you will most certainly enjoy. Hit a like on this video and leave a comment below. See you guys in the next one.